Good morning, everybody, and welcome to the live recording or live lecture for Module 3. Today we're going to be looking at solving a variety of equations and inequalities, which is a focus of Module 3. So the first thing I want to know is if you all can hear me, and if you can just give me that smiley face that's right above your name. Excellent. So I've seen most of us. Yep. All right, so it looks like everybody can hear us. And again, there's some ways to participate during the live lecture. One, you can just kind of chat away in the chat box. Sometimes I'll ask you to use that check mark that was kind of to the right of the smiley face to answer some yes or no questions. Sometimes I'll ask you to use that smiley face. And if you have a question, you can certainly raise your hand at any time. You might even want to grab that pencil tool and help me out solving some of these problems. So we're going to go ahead and get started, and we're going to focus on solving linear equations. Now, I always have to start with a funny, and so you can read the comic. It says, just a darn minute, yesterday you said x equal to 2. And so we're going to start by thinking about solving, and for me, I always like to check the reasonableness of my results. So if x was indeed 2, then 2 plus 2 is 4, and that wouldn't give us 5. So let's get started. I'm going to give a moment to read through it, and then we're going to do kind of a poll, whether we think the equation is A or B. So here we go. Drum roll, please. All right. So I have a friend, Maggie, and she's wonderful. She teaches math. And she was thinking about the secret number. And she didn't want to tell me her secret number, but she gave me these clues. She said that if I took 4 more than half of her secret number, I would get the same thing as if I took 1/3 of 9 more than her number. And so I really want to find out what Maggie's number. In order to do that, I don't want to guess and check a whole bunch of numbers because I might be here for a while. I'm going to use algebra to help me out. So I'm going to let S be Maggie's secret number. And I have these two equations that look very similar, but they have one different operation in them. And I want you to read again through Maggie's clues and either type in A or B if you think the equation in A matches Maggie's situation or if the equation in B matches Maggie's situation. All right, got a lot of people typing. Excellent, excellent. So most of us are saying it's B, so let's look at it, and before we get to B, let's look at A first. And so sometimes I just literally try to translate the equation. So I see that I have 4 more there it goes, 4 more than half of Maggie's secret number. Right, so I have that piece. But this piece right here is telling me that I have 9 more than 1/3 of Maggie's number. And I want 1/3 of the total quantity, 9 more than her number. And so when I look at kind of order of operations, in the second equation, S plus 9 says I take Maggie's secret number and I add 9 to it. And then I want 1/3 of that result. So I can see that B is going to be the equation I'm looking for. Again, in A, I was looking for 9 more than 1/3 of our number. And so sometimes we're translating these words into equations, and we have to be particular about the order of operations. So let's go ahead and solve this. And so I want you to take a moment and tell me what might be your first step if you were trying to solve the equation for Maggie's secret number. And I'll give you a hint. There's many, many ways to do this. I feel like there should be background noise or music while you're typing away. Excellent. So I have 2 different strategies that people are typing. One said I'm going to use the distributive property. Okay. And another one said that you want to, I see, get rid of the fractions. And so I want to make it more efficient by trying to multiply both sides in order to eliminate, even though we love them, eliminate the fractions. Right? So 2 very excellent ways to solve this. So I'm going to look at the first one using that distributive property. And so can someone help me out? If I use the distributive property, I'm using the distributive property over addition. So what would I get when I use the distributive property on that right-hand side? Excellent. So I'd have 1/3 S plus 1/3 of 9, which would give me 1/3 of S plus, well, 9 divided by 3 is 3. And so you can see how it was very similar to that A in the last slide, but I now have 1/3 S plus 3, or 3 more than 1/3 number. So now that I have the distributive property, let's write down the entire equation so I can solve for it. 4 more than half of Maggie's secret number is the same as, well, we knew it was 1/3 of 9 more than her number, or equivalently 1/3 of her number plus 3. And so now what would I do? Excellent. So I see people typing in combine like terms. So I'm going to go ahead and I'm going to subtract 1/3 S from both sides. I could have subtracted 1/2 S from both sides if I wanted to. And then since I'm bringing my S variables on the left-hand side of my equation, I'm going to go ahead and subtract 4 from both sides. Now, if you'd like, you could do that in 2 separate steps, or some of you can just do it without writing down those steps, so whatever is efficient for you. And so now I have 1/2 S minus 1/3 S on my left-hand side. And I know step 4 minus 4 cancels to make 0. And on the right-hand side, I see 1/3 S minus 1/3 S is going to cancel and make 0. So I'm left with 3 minus 4, which is a -1. And so now I got to look at those fractions, and I got to think about, well, how can I subtract 1/3 S, or 1/2 S minus 1/3 S? And I see some people helping me out. Excellent. So we find that common denominator, which some of you are writing down 6. So I know that, excuse me, a little tickle there. I know that 1/2 is equivalent to 3/6 S, and then 1/3 is equivalent to 2/6 S, and that's still equal to 1. And so I have 3/6 S minus 2/6 S, so I get 1/6 times S is equal to -1. So now how am I going to tackle this? Oh, 2 different strategies. One says I can divide by 1/6, and that's 100% legitimate. I could divide both sides by 1/6, and then I would realize that I have -1 all divided by 1/6, and I would have to multiply by the reciprocal of that divisor, so it would become -1 times 6/1, or -6. I see someone else said, well, I could just multiply both sides by 6, and that would be another great strategy, because 6 times 1/6 is 1. And so now I have Maggie's secret number is 6 times a -1, which was that -6. And before we use that second way to solve, let's go ahead and make sure that we have that right answer by checking the reasonableness of our results. So if I know Maggie's secret number is -6, I want to know what 4 more than half of Maggie's secret number is. And I want to make sure that that is indeed equal to 1/3 of 9 more than Maggie's secret number. Or I could have wrote it as -6 plus 9. So let's see, half of -6 is -3, so this would be 4 plus a -3, and that's going to give me 1. Over here, I have, let's see, 9 plus a -6 is 3, so I have 1/3 of 3, and indeed both give me 1, and so I have Maggie's secret number. So some of you said, well, instead of using the distributive property, I could just multiply both sides of my equation by some number to kind of eliminate those fractions. So I'm going to rewrite the equation down here. And anyone want to help me out what I might multiply both sides by? Excellent. So I chose 6, and the reason I chose 6, you can kind of see it down here. That happens to be the least common multiple of 2 and 3, or that common denominator for 1/2 and 1/3. So I'm going to go ahead, and I got to be very careful because I'm multiplying everything on that left-hand side by 6. And over here, I'm multiplying by 6 as well. And so now we've got to be very careful about the rules or properties that we use. So on this left-hand side, we would be, again, using the distributive property. So I would see that I have 6 times 4, or 24, plus 1/2 times 6s, which would give me 3s. Now over here we have the distributive property because we were distributing over addition. Now on this side we have something a little bit different. Even though we see those parentheses, I have 3 quantities being multiplied together. And so I can multiply in any order using the commutative property. So I could take 1/3 times 6, and that would give me, let's see, 1/3 of 6 is 2. So I'd have 2 times the quantity of s plus 9. So I could have done the distributive property first with that 1/3 and then multiplied everything by 6, or I took a shortcut and said, okay, I know that 6 times 1/3 is equal to 2. And the reason why I could do that is if you think of just, let's get rid of the fractions in the s plus 9. If I had 3 times 2, and then I was going to multiply by 6, so I have those 3 numbers being multiplied. And I can multiply them in any order. I could take 3 times 2 is 6 times 6 more is 36, or I could have took 6 times 3 to get to 18 and then double that to get to 36. So I got to apply that distributive property one more time. So now I have 2 times s plus 2 times 9, or 18. And now I have this equation. It has no fractions in it, but I'm going to use the same strategy as I'm going to isolate my variable, or I'm going to combine like terms. So I'm going to subtract 2s from both sides. And I'm going to subtract 24 from both sides. And now I have s is equal to, let's see, 2s minus 2s cancels to make 0. So 18 minus 24 is indeed a -6. So when you're approaching these linear equations, just make sure that you know that you can solve them in many different ways, in whatever way works best for you. So let's do kind of a check mark. So check mark if you use the distributive property first and went with this strategy. Excellent. So it looks like almost more than half of you prefer to keep those fractions in there, which I love, and use that distributive property. So now we've kind of got equations out of the way. So let's take a moment to think about, what do we remember about inequalities? Oh yeah, so someone just gave me lots of love for my little picture up there. So we have three major rules that we kind of look at when we talk about inequality. And I see someone just typed out something about reversing that inequality sign. And so when we talk about inequalities, we're going to be looking at greater than or equal to, less than or equal to. So all those types of inequalities that we're going to look to solve for. So let's start off with kind of the 2 rules that mirror that if we're solving a linear equation. And they say that if I add or subtract any number to both sides, I'm not going to change that direction of that inequality. So I can treat it like an equal sign, and I'm just going to add and subtract to both sides. As long as I do that, I'm kind of maintaining that solution. And at the same time, I can multiply and divide by any positive number, including 0. If I multiplied both sides by 0, I would eliminate everything, and so that wouldn't help me. But I can multiply by divide anything by some same positive number, and I'm not going to change the inequality. So let's investigate these 2 rules with our example that's given below. And I'm going to give you some moments to start solving this task. 2x plus 1 is greater than 4x plus 3. Kind of chat with me, or grab that pen if you're daring, about how we might solve this 2x plus 1 is greater than 4x plus 3. Excellent. So someone told me I should, again, think about that same strategy, combine like terms. So I'm going to subtract 2x from both sides. And again, I'm just adding and subtracting any value from both sides, so I don't have to worry about that rule of having to switch directions of the inequality that we'll look at. So I now have, let's see, 1 is greater than 2x plus 3. And then I can subtract 3, thank you, subtract 3 from both sides, and I get a negative 2 is greater than twice x. Excellent. So now you tell me to divide by 2 because I don't want 2 times x, I just want x. And so now I have x, I have negative 1 is greater than x, or if I read it the other way, I have x is less than negative 1. So I'm going to just write it in that fashion. And so there's two, or really 3 ways that I can express my solution. But before I do that, I want to just make sure that I have a valid statement. So this tells me if I take anything less than negative 1, I should have a true statement. So I'm going to just pick on x is equal to negative 2 and check it out. So if I substitute that back in, I want to make sure that my inequality is holding. Oops, I want to put a negative 2 there. Yeah, so people are giving that check mark because I can now see that 2 times negative 2 is negative 4 plus 1, and negative 4 plus 1 is a negative 3. And then on the right-hand side, I have negative 8 because that's 4 times negative 2. So negative 8 plus 3, that's a negative 5. And I'd see that negative 3 is greater than negative 5. So now let's look at, well, here's one way I can tell someone the solution. I don't want to have to write all those solutions because I'd be here forever. I could do it graphically, and the way we do it graphically, there's kind of 2 versions. One, I could say, well, I want all x less than negative 1, so I'm going to put this open circle at negative 1, just indicating I can't pick negative 1, but I can pick anything really, really close to negative 1 or all the way down to negative infinity. So that's one way I could express it. Some people prefer, instead of that open circle, they put a parenthesis indicating the same thing, that I'm going to go all the way up to but not including negative 1, and kind of give me all my choices that I can pick along my number line. I could also write this in what we call interval notation. So I'm going to give someone a moment to think about how they might write this in interval notation, that x is less than negative 1. Excellent. Right, so that was a clever way to put in negative infinity, negative INF. So I could go all the way down to negative infinity and then all the way up to, but not including negative 1. And you're going to see 2 things. I'm going to use parentheses every time I write negative infinity or infinity. And then I got to decide if my inequality is strictly less than or equal to. And since this was strictly less than, I'm going to use the parentheses to indicate that I can't include negative 1. So if I substitute in negative 1, I'm not going to get a true statement. So that's kind of the quick look at inequalities. And so now let's get to that rule that we kind of chatted about, and someone was talking about reversing that inequality. And so that's my 3rd rule. And that says when I multiply or divide by a negative number on both sides, that's when I have to think about reversing my inequality. So let's look at an example, and all this is saying is that a negative x, or the opposite of x, has to be greater than 4. So I'm going to try to visualize it. Over here is the opposite of x. Right, so if I want the opposite of x, or the negative version of x, or it really doesn't have to be negative, the opposite of x is greater than 4, then what types of values can I pick for x? Excellent. So someone said negative 5, negative 6, negative 7, right? So I could pick anything over here. These are my values for x. For example, if I picked x is equal to negative 5, I'm going to see the opposite of negative 5 is a positive 5, and that is indeed greater than 4. So you are just telling me that I'm going to pick any x value that's less than negative 4. And you see kind of the process of what happened is really mechanically, I was multiplying both sides by a negative 1. So I would get negative 1 times negative x, or just x. And then I reverse that inequality to make sure that I have my answers, that x is indeed less than negative 4. So doesn't anyone, besides kind of that graphical representation, kind of know maybe a reason why we're reversing that inequality? Got a little unsmiley faces. Right, so one way I can look at it, besides looking at it graphically, is I think about, well, just like equations, I can solve inequalities in a variety of ways. And instead of multiplying by a -1, I want to make x a positive x. And all I'm going to do is I'm going to, instead of dividing, I'm going to add a positive x to both sides. And so now I have 0 is greater than 4 plus x. And then finally, I'm going to subtract 4 from both sides. And I'm going to see I have x is less than -4. And so when I add that positive x, I'm taking x to that opposite side. And we can see there's kind of that relationship of reversing that inequality. So I'm going to let you start on a task. And here's the task I'm going to let you start on. And I want you to tell me how you might solve this problem. And as you're working, if you get that far, I want you to see if we think the answer is A, x is less than or equal to a -1, or B, x is greater than or equal to a -1, or I guess C, Dr. Koziak typed up an answer too quick and it's not there. All right, see a lot of people working. I'll keep working for a moment. All right, so I'm getting a lot of things. Some just giving me the first step. And again, I see two different ways. One is shouting out distribute, another one shouting out divide. All right, I see a overwhelming response. I'm looking at A as well. So I'm going to take someone's strategy of dividing first and look at how I might solve this, and then we'll come back to see if indeed A is the correct answer. So the first thing I'm going to do is I'm going to rewrite it down here. Rewrite that inequality. And I could divide first. Right, so I'm going to divide by, excellent, -3. And if I divide by -3, what's going to happen to that inequality sign? Excellent. So we're going to reverse it, right? Change direction. So now I have -3 divided by -3 cancels to make 1. So I have 2x minus 1 is less than or equal to 9 divided by a -3, which is a -3. And then I could go ahead and solve it. I add 1 to both sides. And I get 2x is less than or equal to a -2. And if I divide both sides by 2, I indeed see x is less than or equal to a -1. And so that was a great strategy. I realized that 3 was a factor of 9, so they would divide very easily. So I could also approach using the distributive property. And if I use the distributive property, I would see that I would have -3 times 2x, or -6x, and -3 times a -1 is +3 is greater than or equal to 9. And now I can approach it two different ways. I could subtract 3. And I'd get -6x is greater than or equal to 6. And now I could go divide by -6, and if I divide by -6, I'm again going to reverse that inequality, and 6 divided by a -6 is indeed a -1. Or if I'm at this step right here, I could add 6x to both sides. And so I'd get 3 is greater than or equal to 9 plus 6x. And then I could subtract 9 from both sides, and I would see 3 minus 9 is a -6. And now I don't have to worry about reversing that inequality. So I could just divide by 6. and I would still get that x is less than or equal to -1. So all those strategies, and I get to pick which one I like. Well, now I have x is less than or equal to -1. I could check that by picking anything less than or equal to -1, just to make sure. If I picked on -2 again, I want to check to see if I indeed get something greater than or equal to 9. So 2 times -2 is -4, minus 1 more is -5, and -5 times a -3 is equal to 15. And I do see that I get something greater than 9. So we kind of see it at interval notation. I could put it into that, inequality notation, so I can put it into that interval notation. And how would I write this one? Excellent. So I see -inf again, or -infinity, and this time I can include -1. And so I'm going to make sure that I put a different symbol. In this case, we use a bracket that says, well, if I substitute in -1, I should still get a true statement. So let's go ahead and do that really quickly. So now I have 2 times a -1, which is a -2, minus 1 more is a -3. So I have -3 times a -3. And I would see that 9 is really greater than or equal to 9. So I have that boundary point. So sometimes when we work with linear inequalities, we sometimes have these compound inequalities. And compound inequalities are just, I kind of have 2 inequalities that I'm dealing with at the same time. And I want to know how I might solve this. So I'm going to give you a moment to think about, well, where might my answer be? And so I have some choices. Could x be -5? Could x be -1? Could x be 2 in order to make this compound inequality statement true? Now, hopefully you don't do arithmetic like I do and sometimes drop a negative sign. Well, that one got an applause. I'm glad I'm not the only one at times. The good thing is I can always recheck my answer. All right, so I see some answers coming in. All right, so I see a lot of C's, and if you started with C, it was easier, then you didn't have to check A and B. And so if I use C, I could see that I'd have -3 is greater than 5 minus 2 times 2, because I'm going to substitute x equal to 2, which is 4. And I want that to be less than 7. And 5 minus 4 is 1, and I do know 1 is between -3 and 7. So that's going to be one of our x values that will make this inequality 2. If I pick -1 and did some math, I'd have 5 minus 2 times a -1, or 5 minus 2, which would give me 5 plus 2, or 7. And then we would see that that wouldn't be true because 7 is not less than 7. I'd have to change that inequality sign. So now just to approach solving these types of equations, and really it's, you're treating them as 2 separate inequalities, so I'm going to look at that. 5 minus 2x is less than 7. And at the same time, I'm looking at my second inequality. -3 is less than 5 minus 2x. And I'm just solving them simultaneously. So what I do to kind of one, I'm doing to all 3. Excellent. So someone says, take away 5, and I'm going to take away 5 from all 3 sides. 5 minus 5 in that middle is going to give me 0, and -3 minus 5 more is a -8. And now I have 7 minus 5, which is 2. Excellent. So someone says divide everything by a -2. And if I looked again at them separately, when I divide that inequality, -2x is less than 2 by -2, what happens to that inequality sign? Excellent. It's going to reverse. And if I look at this inequality, again, that would reverse. Thank you. So I have to be careful that I'm following those properties. And now I have -8 minus a -2 is 4. Negative 2 divided by negative 2 would just give me x, and then finally negative 2 divided by, or positive 2 divided by negative 2 would give me negative 1. And so I kind of have x sandwiched between negative 1 and 4. And so I like to just rewrite it with the smaller number on the left-hand side. Oops. I want that strictly less than. And so now I can look at this from a graphical approach that I can only pick, don't want to pick negative 1, so I'm going to put that open circle, and I'm going to pick all values between negative 1 all the way up to and including 4. So I'm going to put a dark circle on 4 just to say I can pick it. And so we could see indeed that when we picked x equal to 2, that was a valid solution. So I'm going to have you help me out and say, how would I write this inequality in interval notation? Excellent. So you said negative 1. I want the parentheses on negative 1 because I can include it, and a bracket because I can include 4. So this tells me I'm going to pick numbers really close to negative 1, but not include negative 1. And here I can include 4. So now we've kind of worked through inequalities. So let's look at absolute value. And one thing that we might remember about absolute value, and I found this and I thought it was funny, absolute values won't put up with negativity. And so we saw the absolute value is always going to make things positive. And so my question is that all we really think about as absolute value? Is it makes things positive and it keeps things positive. So the absolute value of 8 would also be 8. So everyone's saying, yeah, that's what I remember about absolute value. So let's look at a different definition of absolute value, and we'll solve a few more tasks before we kind of sign off for this live lecture. Really what we look at is this absolute value is the distance that any number is away from 0. And since we're talking about distance, it's always positive. So if I go back to my comic, it was looking at the absolute value of negative 8. So that's right here. And all it's telling me, the absolute value, is it wants to know how many units from 0 negative 8 is sitting. And I could see that I'd have to walk 8 steps in order to get from negative 8 to 0. So that's why the absolute value of negative 8 is 8. At the same time, if I'm out here at positive 8, I'd have to walk this 8 steps in order to get to 0. So the absolute value of 8 is also 8. So it's that distance. So I want you to think to yourself 2 critical questions. Using this interpretation, what does the absolute value of x mean? And could we ever get the absolute value of something equal to a negative number? Excellent. So thank you. So you're looking at the absolute value of x, and you gave me, you actually solved it. You said, well, either x could be equal to a negative 4 or x could equal to 4. Because what I was looking as the distance from 0 is 4 units. And the only 2 numbers that are sitting 4 units away from 0 happen to be negative 4 and 4. And so unlike those linear equations, when I get absolute value equations, I'm actually have that possibility of getting those 2 different types of solutions. So now why can't x be equal to a negative 4? Excellent, because we're talking about distance, and this would say the distance from 0 is a negative 4 units, which in kind of our world, we always want distance to be positive, although most of the time I feel like I'm walking backwards 4 steps. But in this case, we say that this distance always has to be positive, so there's no x that I can pick where I'd have a distance from 0 being negative 4 units. So let's look at solving one of these. And they're going to be kind of the same strategies that we use for linear equations and inequalities. We kind of isolate the variable, or in this case, that absolute value, so that we can deal with these types of equations that look at the absolute value is equal to some number. So first, a poll. So I have this absolute value inequality, or excuse me, this absolute value equation. And this is an equation because expressions don't have that equal sign, so my absolute value equation. And do we think that there's only one answer that's going to solve this, or do we think that there would be two values that would actually make this statement true? So you're all, that was very quick. Everyone said B. I think there's going to be two answers. And so let's think about how we might solve this. And there's kind of the same steps. So I'm going to isolate the absolute value. And this is the same thing as like isolating the variables. And then I got to think about those two equations because now I'm talking about distance. So I'm going to do the first step of isolating that absolute value. So excellent. Someone said I'm going to add 7 to both sides. And if I do that, I have 3 times the absolute value of x plus 2. Oops. That absolute value sign is equal to 21. Excellent. So now you're all typing divide, divide, divide. So I'm going to divide both sides by 3. So I don't want 3 times that absolute value. So I get x plus 2 is equal to 7. And that's the absolute value of x plus 2 is equal to 7. So now this tells me that if I was looking at, I want to find a quantity x that when I add 2 to it, I'm within 7 units from 0. So that's what this is telling me. Take any value of x, add 2, and I'm going to be within 7 units. And so I could see that that quantity x plus 2 could be 7 units to the left of 0, or that quantity of take x and add 2 could be 7 units to the right of 0. So now I see I have those two equations. Either x plus 2 is equal to negative 7, or it's sitting 7 units from 0 on that left-hand side, or x plus 2 is equal to a positive 7, sitting 7 units to the right of 0. And now I can solve this just like I would in linear equation. So I'd have x is equal to a negative 9, yep, and x is equal to 5. And so I indeed have those two values. Now I'm going to go ahead and always check the reasonableness of my results. So if I substitute in negative 9 for x, I want to make sure that I get 14. And so negative 9 plus 2 is a negative 7, and the absolute value of negative 7 is 7 units. So I'd have 21 minus 7, which is indeed 14. And you're going to see very similarly if I substitute in 5. Yeah, look what's happening in that absolute value. Now instead of getting a negative 7, I got a positive 7. That's still 7 units from 0. And I can see that indeed I get 21 minus 7 is equal to 14. So again, same strategies. Now I saw someone said before we would add 7 to both sides that I could divide by 3, which is also a valid strategy, but I have to be very careful when I do division, because if I wanted to divide 3 first, I'm going to have to divide the whole quantity by 3. And so now I'd have kind of 3 times the quantity of x plus 2 divided by 3. But I'd also have negative 7 divided by 3. And that's equal to 14 thirds. And so I just would have to be very careful. And then I could add 7 thirds to both sides, and I could see I'd get back to where I started from. So if I add 7 thirds to both sides, I'd have the quantity absolute value of x plus 2 is equal to 14 thirds plus 7 thirds, which is 21 thirds. And that would also be 7. So again, either strategy, if you like adding 7 and then dividing by 3 as your strategy to isolate that absolute value, or you're going to divide by 3 and just be very careful that you're dividing all terms by 3. So the last thing that we're going to look at is now putting those absolute values together with inequalities. So I have the absolute value of x is less than or equal to 4, and I want you to just kind of type in some values of x that would make this true. All right. I'm just marking them when I see them. Excellent. All right, so I see a lot of choices that I can, someone just told me I'll pick anything between negative 4 and 4, and that's going to work. So if I pick negative 2, the absolute value of negative 2 is 2, and that's definitely less than or equal to 4. And so if you remember that distance argument, this says I want the distance of x from 0 to be within 4 units. Right, so I could go all the way out and be within 4 units on the right side of 0, and I can do the same thing to the left hand of 0. And I could see that my inequality then becomes a compound inequality because I can pick any value of x between -4 and +4. Right, and so when I start solving these things, the first thing I'm going to have to do is isolate that absolute value expression, and then I'm going to have to figure out, do I write this as a compound inequality? Am I kind of putting it between two numbers? Or on the other hand, what if I gave you the following? The absolute value of b is greater than 4, and I want you to just kind of shout out or write on here some values of b that would work. Yeah, so you're giving me a whole bunch of them. I see people typing 5, 6, 7, 8, who do we appreciate? I won't go any further. And then I can pick anything like, let's say, -5, -6, -7, all the way down, because if I plugged in -6, the absolute value of -6 is 6. And -6 is more than 4 units away. So unlike the less than or equal to, this says I want to find values of b that are more than 4 units away from 0. And so if I was going to do that, I would see that I'd have actually 2 statements. First, I could pick anything greater than 4 for b, or I could pick anything that b is less than -4. And so I can look at all these numbers. B is less than -4, B is greater than 4. And now I have kind of this 2 inequalities that I'm looking at. So when I first solve these things, I first isolate that absolute value sign, and then I think about, did I get a compound inequality, like the equation x is less than or equal to 4, or do I get these 2 inequalities set up because absolute value of b is greater than 4? So 2 last problems for this morning is I want you to think about solving this absolute value inequality. Excellent. So someone tells me divide by 3 right away because I want to isolate that absolute value. So if I divide both sides by 3, I get the absolute value of 2x minus 1 is less than 3. And now it says, okay, I want to take twice a number and subtract 1, and I want to be within 3 units of 0. Excellent. All right, so I want to kind of wedge 2x minus 1 between -3 and 3, because that's the only way that I could be kind of within, not including -3 and 3. All right, so I want to be kind of less than, I guess, 3 units, just in case that within meant we're including them. And so now I could see that I have this, I can change this absolute value inequality to a compound inequality because I want to be within 3 units. And then I can solve it just like our compound inequality, add 1 to all 3 sides. So I have -2, 2x, and 3 plus 1 is 4. And then I'm going to divide by a +2, which will keep those inequalities in the same direction. So I'd have -1 and 4, and, oops, sorry. We probably should divide by 2, so that's why I should show my work. So now I said 4 divided by 2 is 2, so now x is between -1 and 2. And so when I set up this is telling me that 2x minus 1 is going to be between -3 and 3. And so when I solve for x, it tells me I'm going to sandwich x between -1 and a +2. And then I could go ahead and check. I see 0 in my interval, so I'm going to substitute in 0 because that's easy for me to make sure I have the right inequality. So I have 2 times 0 is 0 minus 1 is negative 1. So 3 times the absolute value of negative 1. Well, that's just the same as 3 times 1, and indeed that's less than 9. So one last one, now I'm going to do is switch that inequality on you. Now notice what I did is now I want it to be greater than or equal to 9. So the same kind of isolating that absolute value is 100% correct. I could divide both sides by 3. And now I have 2x minus 1 is now, the absolute value is now greater than or equal to 3. And in that case, I want to be 3 units or more from 0. So when I take a number, I multiply it by 2 and I subtract 1, I want to be 3 units or more from 0. And so yeah, I see someone said, well, now we have 2 inequalities, and you're absolutely correct. I either have 2x minus 1 is less than or equal to a negative 3, or I have over here 2x minus 1 is greater than or equal to a positive 3. So I have these 2 spots that I'm dealing with, and now I solve it. Excellent. So add 1, I get 2x is less than or equal to negative 2. Divide both sides by 2, and this time I promise I'll divide both sides by 2. I get x is less than or equal to a negative 1. And over here, if I did the same thing, I get 2x is greater than or equal to 4. And now I see that x, divide both sides by 2. Excellent. So x is greater than or equal to 2. And so now I can see that if I picked x, I take x, anything less than negative 1 is going to help me out. And if I pick an x that's greater than 2, it's going to help me out. And so when I write this, I can write this in interval notation. The first one, x is less than or equal to negative 1. Excellent. Or x is greater than or equal to 2. And so since it can be equal to 2, I'm going to put that bracket. Excellent, thank you, 2 to infinity. When someone's typing in a big U or a capital U, and sometimes we use set notation, that set notation, that kind of looks like a capital U. It's unioning or joining these two. And so it says I can either pick numbers from negative 1 to, or negative infinity to negative 1, or from 2 to 8. So before we kind of sign off on solving absolute value inequalities, or any of the things that we were looking at, I want to just thank you for coming to the live lecture today, and just figure out if we have any questions about linear equations, inequalities, or absolute values. All right, now I'm getting a lot of smiley faces. Oh, thank you too. Have a wonderful day. I'm signing off until we have live lecture 4, which will be coming up very soon. Have a wonderful day.